Alright, the second type of linear equations that we're going to look at is solving linear equations involving fractions. This comes from section 2.3. Some things that you want to maybe review before looking at this section is you want to be able to find the LCD for a set of fractions, understand how to multiply fractions by an integer, understand how to solve basic equations using addition and multiplication properties, and understand how to check your solutions by plugging in the result into the original equation. Upon completing this presentation, you will be able to solve equations involving fractions by clearing the denominators and or solving equations by rewriting all terms with the same denominator. So our procedure for solving equations involving fractions is going to be basically the same. The only thing that we are going to change in terms of our procedure is the first step. Remember that in the previous section, we said our first step was to clear parentheses. In this section, or this part of the section, we want to clear the denominators. In order to do this, we want to find the least common denominator, and we can do one of two things. We can multiply both sides of the equation by the LCD and cancel the denominators. Notice that by multiplying all terms, we are essentially multiplying both sides of the equation by the same number, so it is allowed. The second way that we can do this is rewrite all terms with the LCD and clear the denominators. We'll explain why this is possible as well as we look at examples. From there, the rest of the steps are going to be the same thing as they were in the previous presentation. We want to simplify each side by combining like terms. We want to move all variable terms to one side and all constants to the other using the addition property of equality. We want to use the multiplication property of equality to isolate the variable by dividing both sides of the equation by the coefficient. From there, you want to check your solution by substituting the number back into the original equation and simplifying both sides. So let's look at some examples. Now, these examples, as I said, I'm going to do this using two different methods that will essentially be the same thing. If we look at example A, we have y over 12 plus 1 over 6 equals y over 2 minus 1/4. I'm going to show you first the method that works best for me, but then I am going to show you another method that students have a tendency to relate to a little bit better. So my first step on this is I want to find the LCD for all of the fractions in the problem. So remember that the LCD is a number that is divisible by all of these numbers in the denominator. So I want a number that is divisible by 12, 6, 2, and 4. Well, for this problem, my LCD is going to be 12. 12 is divisible by 12. 12 is divisible by 6. It's divisible by 2. And it is divisible by 4. So from here, what I want to do is I want to multiply both sides of the equation by 12 and distribute. So I'm going to do this in two steps so that you can see kind of our rules that we have used before. So I'm going to multiply both sides by 12, and I want to distribute to each one of the terms. So I'm going to get 12 over 1 times y over 12 plus 12 over 1 times 1 over 6 equals 12 over 1 times y over 2 minus 12 over 1 times 1/4. Now from here I want to go ahead and multiply, and basically all we're wanting to do is we want to cancel all of our denominators. If we picked a least common denominator that is actually common, all of our denominators should go away. So in the first term, my 12s, remember we are multiplying fractions, my 12s cancel completely, leaving me with just a y. In my second term, 12 and 6 are both divisible by 6. I get 1 and 2. And if I multiply straight across, I get 2 over 1, or just 2. On the right side of the equation, I can cancel my 12 and my 2. Both are divisible by 2. 2 divided by 2 is 1, and 12 divided by 2 is 6. So I am left with 6 times y. And in the last term, 12 and 4 are both divisible by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. And if we multiply straight across, we get minus 3. So now, the rest of this is going to be fairly easy. We're basically back to what we did in the previous presentation. So my next step is I want to go ahead and move my like terms around. I can't simplify either side. There's no like terms to combine. So I want to move my variables to one side and my constants to the other. For this one, remember it does not matter which direction you move things. For instance, on this one, I'm going to go ahead and move my variables to the right. So I'm going to subtract y from both sides. So I get 2 equals 5y minus 3. The y's canceled out on the left side. And then from there I want to move, since my variables are on the right, I need to move my constants to the left. So I'm going to get rid of the minus 3. I want to add 3 to both sides. So I get 2 plus 3 is 5 equals 5y, and my 3's cancel. From here, I can go ahead and get rid of, to get y by itself, I need to get rid of multiplying by 5. And so to get rid of multiplying by 5, I want to divide by 5. So 5 divided by 5 is 1. So we get 1 equals y. And we're done. Now, as I said, this is the first method that you can use in order to solve this problem. The second method that you can use is to rewrite everything with the same denominator. We still want to find the LCD, which we've done. From there, what I want to do is rewrite everything with a denominator of 12. So let's go ahead and write out our problem again. We have y over 12 plus 1 over 6 equals y over 2 minus 1/4. So if we go ahead and rewrite everything with a denominator of 12, remember that was our LCD, The first fraction, I'm done. I don't have to do anything else. It already has a denominator of 12. So I'm just going to go ahead and bring that down. For the second fraction, how do we get from 6 to 12? In order to get from 6 to 12, I need to multiply by 2 on the bottom, but remember that when we're working with fractions, whatever you do to the bottom, you have to do to the top. So we get y plus 2, 2 over 12. On the right side, in order to get from 2 to 12, we want to multiply by 6. So I'm going to multiply 6 to the bottom, and remember, we want to do the same thing to the top. So we get 6y over 12. And for the last term, in order to get from 4 to 12, I want to multiply by 3. Whatever I do to the bottom, I do to the top, so we get minus 3 over 12. Now, the trick when doing this, again, our goal is to get rid of the fractions, because fractions are just going to make it much more complicated. Now, the trick when using this method is if all of our denominators are the same, do we really need the denominator anymore? And the answer is no. From here, if our denominators are all the same, we can cancel them. And what we are left with is y plus 2 equals 6y minus 3. From here, notice that our equation, y plus 2 equals 6y minus 3, is the exact same equation that we got when we did the other method. So this is just going to involve one more step than multiplying everything by 12. From here, you can use the same method for solving that we did, and I'm not going to make this presentation any longer. You can follow along with the rest of the steps from there. So let's go down to example B. Example B, we have x over 5 minus 4 equals negative 5 over 2. So the first thing that I want is a least common denominator. Now remember, we just want the denominators, so the 4 is not going to be part of this step, as it is not in a denominator. So my least common denominator is 10. Now, one of the important things to keep in mind is this 4, the reason that I chose this problem, is this 4 has a tendency to trip students up. And the main reason is because remember that when we do this next step, you have to multiply all terms by the LCD, or you have to rewrite all terms with the LCD. That includes this 4. So if we start by multiplying everything by the LCD, I want to multiply x over 5 times 10 over 1. I want to multiply 4 times 10. Since we're going to be clearing denominators, I'm not going to worry so much about putting this in fraction form. And finally, we have negative 5 over 2 times 10 over 1. If we go ahead and cancel from here, we get our 10 and 5 are both divisible by 5, leaving me with a 2 times x gives me 2x, minus, here we're just multiplying, we are 4 times 10, we're just multiplying, we don't need to cancel. 4 times 10 is 40, And finally, we get 2 and 10 are both divisible by 2, giving me 1 and 5. If we multiply straight across, we get negative 25. And so we get 2x minus 40 equals negative 25. Now, before we continue solving this, I do want to go ahead and show you the second method in order to set up this problem. So we have our original problem, x over 5 minus 4 equals negative 5 over 2. So in order to rewrite with a denominator of 10, the first fraction I need to multiply the bottom by 2 and the top by 2. For the second term, I need to start by writing this as 4 over 1. And same thing, I want to multiply the top by 10 and the bottom by 10 in order to get a denominator of 10. And the last fraction, in order to get from 2 to 10, I need to multiply by 5. Whatever I do to the bottom, I do to the top. So if we go ahead and simplify each one of these terms, I get 2x over 10 minus 40 over 10 equals negative 25 over 10. Since all of my terms have the same denominator, I can go ahead and cancel it. And we are left with 2x minus 40 equals negative 25, which is exactly what we got using the other method. So now from here we do want to finish solving. So if we finish solving this, I'm going to go back to the left side. Let's go ahead and see what we can do. We don't have to distribute, we don't have to combine like terms. We're going to start with our solving steps. And so my first thing that I want to do is get rid of minus 40 from the left side so that I get my x's by themselves. So we're going to add 40 to both sides. To get rid of subtract 40, we do the opposite. The opposite of subtracting 40 is adding 40. My 40s cancel out. That leaves me with 2x equals 15. Since we have different signs, we want to subtract and keep the sign of the larger number. And finally, in order to get x by itself, we want to divide by 2. Here we have 2 times x. The opposite of 2 times a number is dividing by 2. And so we get x equals 15 over 2. Now, you might be sitting here thinking, wait, that doesn't look good because it's a fraction, but just remember, fractions are numbers. They are allowed as answers. So this is perfectly fine. As this is a relatively nice fraction, you can also get away with writing it as a decimal of 7.5. Now, on quizzes and exams, I'm not going to require that you show the check step for this, but it is still a good idea. Now, when I work with fractions, in terms of how do I check it, I use a calculator. So for instance, what we want to do if we're going to check in our calculator, we want to go on this last problem. You may want to use the decimal form. I want to do 7.5 divided by 5 minus 4. On the right side, we still have negative 5 over 2. So go ahead and type in your calculator, what is 7.5 divided by 5? You should get 1.5. Take that number and subtract 4, and what do you get? Well, you should get negative 2.5. Okay, good. We're done with the left side. So now let's look at the right side. In your calculator, plug in negative 5 divided by 2. And what do you get for your answer? You should get negative 2.5. That checks out. All we want to know is, does the left side equal the right side? So go back to problem A and do the same thing in your calculator. Enter in 1 divided by 12 plus 1 divided by 6. Simplify that down. You may want to use the fraction features on your calculator in order to do that, but simplify it down and you should get a final answer. You should get a final answer of 1/4. Similarly, on the right side, you should also get an answer of 1/4. If you have questions on how to do this in your calculator, please bring your questions to class so that I can show you how to use the fraction features in your calculator, or we can look at more examples in class to show exactly what we want to do here. So solving linear equations, when are we going to see this again? Solving more complicated equations will come up throughout the course of the semester, but ultimately they are all extensions of solving linear equations. So as long as you can solve linear equations, you should be able to solve the more complicated ones. For instance, when we get to quadratics and radical and rational equations. We will revisit and expand the idea of solving more complicated equations when we talk about solving formulas for specific variables, linear inequalities, systems of equations using substitution method, quadratic equations, rational equations, radical equations, etc. We will extend the concept of what we did when solving linear equations when we work with polynomials and negative exponents. Once you feel that you are comfortable with the material presented here, try the following problems on your own and see what you come up with. We will review these in class. Please make sure that you bring any questions that you have over this material to class as well. We may need to do more problems because this is one that is just a little bit more complicated. It is a new section, and so if we need more problems, again, make sure that you ask.